Alright guys, so we're going to look at section 8.5, which is applications of matrices and determinants, so we can see where we might use them in real life. Okay, so the first thing we're going to look at is we're going to look at Cramer's rule, which deals with determinants, which we went over yesterday. So if you're given a system a1x plus b1y equals c1 and a2x plus b2y equals c2, you can use Cramer's rule to find your x and y. Okay, so to find your x, you find the determinant of c1, b1, c2, b2, and you divide it by the determinant of your leading coefficients, a1, b1, a2, b2. Then to find your y, you do similarly, determinant of a1, c1, a2, c2, divided by the determinant of your leading coefficients, a1, b1, a2, b2. Alright, so if I look at example 1a, I'm given 4x minus 2y equals 10, 3x minus 5y equals 11. And I need to find my x and y. So I know that x is equal to the determinant of c1, b1 divided by c2, b2, divided by the determinant of your leading coefficients. So a1, b1, a2, b2. Okay, so if I actually figure out what that would look like then, I know that that means that I'm taking the determinant of my c1 is 10, my c2 is 11, divided by my b1, which is negative 2, negative 5. And my leading coefficients are 4, negative 2, 3, negative 5. Okay, well, to find determinants, we went over that yesterday. Determinants of 2 by 2 matrices, you cross multiply. So 10 times negative 5 gives me negative 50. And then you subtract your other cross multiple. So 11 times negative 2 is negative 22. If I do the same thing for the denominator, 4 times negative 5 is negative 20. Minus 3 times negative 2 is negative 6. Well, these minus negatives turn into positives. So negative 50 plus 22 is negative 28. Negative 20 plus 6 is negative 14. And negative 28 divided by negative 14 gives me positive 2. So I know x is positive 2. If I do then the same thing to find my y, I know that y is equal to the determinant of a1 c1 over a2 c2 divided by the determinant of my leading coefficients, so a1 b1 a2 b2. And so if I plug in my values for that, I know that my A1 is 4, and my C1 is 10, my A2 is 3, and my C2 is 11. Then I'm going to divide that by the determinant of my leading coefficients, so 4, negative 2, 3, negative 5. Okay, to find your determinant, you cross multiply and subtract, so 4 times 11 is 44, minus 3 times 10, is 30. We already figured out the determinant of my denominator was negative 14. You can do it again, but we'll just know that it's negative 14. So 44 minus 30 gives me 14. Divided by negative 14 gives me negative 1. So I know that x is 2 and y is negative 1. Okay, so if I do the same thing for then example 1b, 3x plus 4y equals 1, 5x plus 3y equals 9. So I want to start by finding my x. I know that x is my determinant of C1, B1, C2, B2, divided by the determinant of my leading coefficients A1, B1, A2, B2. Alright, so what that actually means is my C1 is 1, my B1 is 4, my C2 is 9, my B2 is 3. And my leading coefficients are 3, 4, 5, and 3. So if I go ahead and actually simplify those determinants, I know that I have to cross multiply and subtract. So 1 times 3 is 3, minus 9 times 4, which is 36. And if I go to the bottom, 3 times 3 is 9, minus 5 times 4, which is 20. Okay, so 3 minus 36 gives me negative 33. 9 minus 20 gives me negative 11. Negative 33 divided by negative 11 gives me a positive 3. So I know x is equal to positive 3. I'm going to do the same thing for my y's. I know that y is the determinant of A1, C1 divided by A2, C2, divided by the determinant of my leading coefficients A1, B1, A2, B2. Okay, and so I know that my A1 is 3, my C1 is 1, my A2 is 5, my C2 is 9. Divided by the determinant of my leading coefficients, and my leading coefficients are 3, 4, 5, and 3. Okay, so then if I find my determinants, 3 times 9 is 27, minus 5 times 1, which is 5. And I already know that the determinant of my denominator was negative 11. 27 minus 5 gives me 22, divided by negative 11, which gives me negative 2. So y is negative 2. Alright, and the last thing that we're going to look at is finding the determinant, or using Cramer's rule to find determinants using a 3-system equation. So if I'm given negative x plus 2y minus 3z equals 1, 2x plus z equals 0, and 3x minus 4y plus 4z equals 2, I need to figure out what my x, y, and z are equal to. So the first thing I'm going to find my x is the determinant of the matrix, except instead of using my coefficients for x, I'm going to replace these front coefficients with my solutions. So I'm going to have 1, 0, 2, 2, 0, negative 4, and negative 3, 1, 4. These coefficients stayed the same, so they just come straight down. And then I'm going to divide that by the determinant of my coefficient matrix. So negative 1, 2, negative 3, 2, 0, 1, 3, negative 4, 4. Alright, and we find determinants of 3 by 3 matrices in our calculator. So if you go ahead and plug those into your calculator, then you can figure out what the top and bottom would be. So plugging that top one into your calculator, you should get a determinant of 8. Plugging that bottom one in your calculator, you should get a determinant of 10. And if I reduce that fraction, then I end up with the fraction 4/5. Okay, if I want to do the same thing to find y, I take the determinant of my initial matrix, except instead of using this column, because that's my y column, I'm replacing that with my solutions. So I end up with the determinant of -1, 2, 3 down the row, then 1, 0, 2 down the column, and -3, 1, 4. The x's and the z's stay the same. The only thing that changes is the y's, and that gets replaced with your solution. And then I divide that by the determinant of my coefficient matrix, which is -1, 2, 3, 2, 0, -4, -3, 1, 4. And you already figured out that the determinant of that bottom matrix gives you 10. So if you go ahead and plug in the top determinant into your calculator, that top matrix, then you should get your determinant for that. And in doing so, you get a determinant of -15. I reduce that fraction, then I end up with -3 over 2. Alright, and then lastly, we're going to find what z equals. And so the same process goes for z. We're going to get rid of our 0, and we're going to replace it with our solutions. Okay, so that matrix becomes -1, 2, 1, 2, 0, 0, 3, -4, 2. Divided by the determinant of my coefficient matrix. Okay, and we know the determinant of my coefficient matrix is 10. If you find the determinant of your numerator of z, then you end up with -16. And if I reduce that fraction, I end up with -8 over 5. Okay, so 3 by 3 matrices, you have to do them 3 different times. Okay, the second part of what we're going to look at today is we're going to look at how to encode and decode matrices using the alphabet to make sentences. Okay, so yesterday I handed out this cryptography sheet. So you all should have the cryptography sheet unless you were gone, in which case it's on the counter over by the bins. Okay, so you're going to need that when we decode. Okay, and so for 7A, it tells you to encode Meet Me Monday as 1 by 3 pieces, and it gives you an encoding matrix A of 1, -2, 2, -1, 1, 3, 1, -4, 1, -4. So I know that I'm going to break these up into 3 by 3 matrices. Okay, so every third letter I have to make a new matrix with the Meet Me Monday part. And so if I look up what M represents from our cryptography sheet, I can see that M is represented by the number 13. Then if I look up E, I see that E is represented by the number 5. So my first coded matrix is 3, 5, 5. Then if I keep going and I look up T, I end up with 20. A space uses the number 0. And then M again uses 13. I know that E uses 5. A space uses 0. And M uses 13. If I look up O, I can see that O uses the number 15. I can see that N uses 14, and D uses 4. And then the last ones, A would use letter 1, Y uses 25, and because I need another number to complete that third matrix, I use a 0 for that space. So now I have 5 different matrices and an encoding matrix, and we're going to multiply them. So 13, 5, 5, multiplied by matrix A. And you guys can use your calculators to do this to make it quicker. Okay, so in doing that, you get a new coded matrix of 13, negative 26, and 21. Okay, if we do the same thing for our second matrix that we made, 20, 0, 13, and we multiply that by matrix A, we end up with a new matrix of 33, negative 53, negative 12. Okay, and so if I keep going with 5, 0, 13 times matrix A, I get 18, negative 23, and negative 42. Okay, my next matrix was 15, 14, 4. So if I take 15, 14, 4 times A, I end up with 5, negative 20, and 56. And then my last one was 1, 25, and 0 as a placeholder. So if I take that times A, I end up with negative 24, 23, 77. Okay, once you have all of your matrices found, then you can take them back out of those brackets and just write your number in a list. So 13, negative 26, 21, 33, negative 53, negative 12, 18, negative 23, negative 42, 5, negative 20, 56, negative 24, 23, 77. That is your new encoding. Okay, so if I do the same thing with the message landing successfully, or successful, and then I use the encoding matrix 1, 2, 2, 3, 7, 9, -1, -4, -7, I need to change landing successful into 3 by 3 matrices. Or into 1 by 3 matrices, sorry. Okay, so I'm going to start looking up those letters on my cryptography sheet. So I know that L is 12, A is 1, N is 14. I know that D is 4, I is 9, and N again is 14. I know that G is 7, a space we use 0, and S is 19. I know that U is 21, C is 3, and the other C is 3. E is 5, and we already figured out that S is 19, so 19 and 19. F is 6, U is 21, and L is 12. So I'm given those 6 matrices that I need to encode using matrix A. So I'm going to do that by multiplying. So my first matrix, 12, 1, 14, I need to multiply that by matrix A to get an encoded matrix of 1, -25, -65. If I take my second matrix, 4, 9, 14, and I multiply that by matrix A, I end up with an encoded matrix of 17, 15, -9. If I take my third matrix, which is 7, 0, 19 times matrix A, I end up with an encoded matrix of -12, -62, -119. If I take my fourth matrix, 21, 3, and 3 times matrix A, I end up with an encoded matrix of 27, 51, 48. If I take my fifth matrix, 5, 19, 19 times matrix A, I end up with an encoded matrix of 43, 67, 48. And lastly, if I take my last matrix, which is 6, 21, and 12, times matrix A, I end up with an encoded matrix of 57, 111, 117. So then in putting those all together, I end up with a new encoding of 1, -25, -65, 17, 15, -9, -12, -62, -119, 27, 51, 48, 43, 67, 48, 57, 111, 117. Okay, so encoding matrices, we just deal with multiplying. Decoding matrices, we also deal with multiplying. However, we're going to have to multiply by the inverse. Okay, so if I'm given the matrix or the list 42, 88, 101, 88, 201, 251, 30, 33, 0, 26, 56, 64, and I'm asked to figure out what that equals, and I'm given the encoding matrix. The original matrix was 1, 2, 2, 3, 7, 9, negative 1, negative 4, negative 7. I need to find my inverse matrix to be able to decode that. And you guys know how to find inverses on your calculator, so if you were to put matrix A into your calculator and then find the inverse of matrix A, the inverse is negative 1, negative 10, negative 8, negative 1, negative 6, negative 5, and 0, negative 1, negative 1. Okay, so we're going to use our inverse matrix in order to decode this. And we're going to group these in sets of 1 by 3 again in order to do that. Okay, so if I take my first matrix, 42, 88, 101, I'm going to multiply that by my inverse matrix. And if I multiply that by my inverse matrix, I end up with the new matrix 13, 5, 5. If I take my second matrix, 88, 201, 251, and take that times my inverse matrix, I end up with a new matrix of 20, 0, 13. Okay, if I take my third matrix, 30, 33, 0, and take that times my inverse matrix, I end up with a new matrix of